Now, in question number 1, we have to sketch the graph of y equals to modulus of 3x minus 2a. Now, to sketch this graph, and in this case, a is a positive constant. When we are when we are asked to sketch the graph, what we have to show is basically we have to show the x and the y intercepts and the direction in which the line would be going. So first of all, for x-intercept, we'll take y equals to 0. So 3x minus 2a would be equals to 0. So 3x would be equals to 2a and x would be equals to 2a upon 3. So this 2a upon 3, we can plot it anywhere over here. So let's say we plot it over here and we'll say that this point is 2a by 3. And then as for the y-intercept, in that case, x is equals to 0. So we'll write y equals to modulus of 3 into 0 minus 2a. We will get minus 2 in modulus sign, which means on the graph, we'll put it positive as it's a modulus sign. So y would be equals to positive 2a. So let's assume 2a is over here. This will be positive 2a. So we will make a line like this, and exactly the same line would be made in this direction. And one thing we can also take into consideration is that this line has a gradient of 3. So if you want, we can show that as well. This line should have a gradient of 3, meaning that for 3 units on the y direction, it will move 1 unit on the x direction. So in that sense as well, you can sketch the graph. But what we have to show is the x-intercept and the y-intercept. We have to make sure that the graph is pointing upwards. It's a V-shaped as there's a model sign. In part B, it says, hence or otherwise solve the inequality 3x minus 2a is less than x plus 5a. Now, with a modulus sign, we can write it as a positive value. 3x minus 2a is less than x plus 5a. And we can also take the negative value 3x minus 2a with a negative sign is less than x plus 5a. Now solving both the equations, so we'll bring the x on this side. So this will become 3x minus x, which will be equals to 2x. And 2a will go on that side. So that will become 5a plus 2a, 7a. So x would be less than 7a upon 2. And in this case, we'll get minus 3x plus 2a is less than x plus 5a. So bringing the x on this side, we'll get minus 4x is less than 5 minus 2 will become 3a. Now, as there's a negative sign with x, so when we flip it around, this will become 4x is greater than minus 3a. And finally, x is greater than minus 3a by 4. And we can now write the final answer as x is greater than minus 3a by 4 and x is less than 7a by 2. Question number 2, we have to solve the equation 2 ln of 2x plus 3 minus ln of 2x plus 5 equals to ln of 3x. Now in the first step, we can write it as ln of 2x plus 3 whole squared minus ln of 2x plus 5 equals to ln of 3x. So this can now be written as ln of 2x plus 3 whole squared divided by 2x plus 5 equals to ln of 3x. Now we can compare both the sides and write this side equals to this. So this will become 2x plus 3 whole squared, that is 4x square plus, so that will become 3 times 2, 6. 6 times 2 is 12x plus 9 divided by 2x plus 5 equals to 3x. Cross multiplying, we'll get 4x square plus 12x plus 9 equals to 6x square plus 15x. Bringing the x squared term on the right hand side, so we can keep it positive. So 4 is 6x squared minus 4x squared, that is 2x squared. 15x minus 12x would become plus 3x. And minus 9 will go on this side to become minus 9 equals to 0. Now we have a quadratic term. We can solve it through factorization or through the quadratic formula. So factorizing this, we'll get 6x minus 3x minus 9 equals to 0. 2x into x plus 3 minus 3 into x plus 3 equals to 0. So the two values of x would be 3 upon 2 and x equals to minus 3. However, what we should know is that this ln term cannot be negative. So the only value of x would be x equals to 3 upon 2. And if you want to know why it cannot be negative, well, the reason is, so let's say we write the equation as y is equals to e to the power of x. This is basic logarithms. So we can write y is equals to x ln of e. Now, basically what we know is that there is no power of x over here that can make this term a negative. It's not possible. Whether I put a negative value over here or positive value, we always get a positive value. So that's why this value of y that we get will always be positive. So the only possible answer would be x equals to 3 upon 2. So in question number 3, it says find the exact value of integral of 3 cos square 5x with the limits 1 upon 4 pi and 1 upon 5 pi. Now to integrate this type of uh, an algebraic term, we'll have to use the identity. So for both sine and cos, if the power is more than 1, we cannot integrate it. We have to use an algebraic identity. Now the identity that we know is, well, we have cos of 2x is equals to 2 cos square of x minus 1. Now, if this multiplies by 5, this also multiplies by 5. So we can write it as cos of 10x is equals to 2 cos square of 5x minus 1. So making cos square 5x my subject, we'll get cos of 10x plus 1 and then divide by 2. So we'll substitute this in place of 3 cos square 5x. We can leave the 3 outside and we can write cos of 10x plus 1. We can even keep the 2 outside over here, dx. Now integrating cos of 10x, so the integral of cos is sine. So we'll get sine of 10x divided by the derivative of 10x, that is 10. And integrating 1, we'll get x. So now our integral is done and we can multiply by 3 upon 2. Or we can simply plug in the limits and then multiply by 3 upon 2 with the final answer. So the first limit is 1 upon 4 pi. So we'll get sine of 10 into 1 upon 4 pi divided by 10 plus 1 upon 4 pi. And then we subtract it from the lower limit, and that is 1 upon 5 pi. So we'll get sine of 10 into 1 upon 5 pi divided by 10 plus 1 upon 5 pi. So this will be 2, this will be 5. So we'll get sine of 5 pi upon 2. And for that, we'll have to use a calculator over here. So, and we'll have to make sure the calculator is in radian mode. So, will this calculator is not working? Okay, so let's use the calculator over here. We have sine of 5 pi by 2. And this would become sine of 2 pi. So, okay, sine of 5 pi upon 2, that is equals to 1. That was simple. 1 upon 10 plus 1 upon 4 pi minus sine of 2 pi, that is 0. So because sine 360 is 0. So that will become 0 and we'll get 1 upon 5 pi over here. And then the final answer would become 1 upon 10 plus 1 upon 4 pi minus 1 upon 5 pi. We can take the LCM throughout now. So the LCM would be 20. So this would become 2 plus 4 times 5. So this will be 5 pi minus 4 pi. So we'll get 2 plus pi upon 20. And now we can multiply the whole answer by 3 upon 2. So when you multiply the whole answer by 3 upon 2, we'll get 6 plus 3 pi upon 40. And that would be the final answer for the integral. In question number 4a, it is given that Z1 is R1 E iota theta 1, Z2 R2 E iota theta 2. We have to show that Z1 Z2 conjugate equals to the Z1 conjugate times Z2 conjugate. Now, when we talk about the conjugate, that basically means if Z1 is written as R1 e to the power iota theta 1, then the conjugate of Z1 would be the same, except that the sign would be different with a negative sign. Now, when it says Z1 times Z2 conjugate, so first we multiply Z1 by Z2. So that will be R1 e to the power iota theta 1 times by R2 e to the power of iota theta 2. And when we are multiplying, so the powers add up, we can write it as R1 and R2, they multiply, and e to the power iota, and in the bracket we can write theta 1 plus theta 2. Now, as we are talking about a conjugate of this, so that will become the same thing, but the angle will become negative. So this will be R1, R2, e to the power, and this will become negative iota of theta 1 plus theta 2. And now we have to prove that this is equals to Z1 conjugate times Z2. So Z1 conjugate would be R e to the power minus iota theta 1 times by the conjugate of Z2 would be R2 e to the power of iota minus iota theta 2. Now, if we simplify this, if we multiply e and the powers add up, we can write it as minus iota theta 1 plus theta 2. So we have to prove in the first step that the conjugate of Z1, Z2 is the same as multiplying the conjugates of Z1 and Z2. So that was the first step. In part B, Z is given as a root of the equation. We have to state the other root and hence find the values of B and C. Now we know in the complex numbers, the roots are complex conjugates of each other. So this is one of the roots. So the other root, let's call it Z2, would be 3 e to the power negative 1 upon pi I. Now, if we have a quadratic form, let's say we normally write it as x minus a into x minus b equals to 0. So instead of x, we have z, and one of the roots is 3 e to the power 1 upon pi iota. The other root is, we'll write it as 3 e to the power negative 1 upon 4 pi iota. And now we can compare it with the original form to find the values of b and c. So expanding the left hand side, we get z squared minus 3z e to the power iota 4 minus iota 1 upon 4 pi upon 4 iota, then minus 3z e to the power, so we are multiplying these two terms now, 1 upon 4 pi, and then we multiply this over here, so this will become plus 9 e to the power, and the powers add up, so this will become 1 upon 4 pi, and when we are adding, so plus minus will become minus 1.4 pi iota. So this will become 0, so this will be 9 e to the power of 0. Plus taking z common over here, what we get is minus 3 e to the power minus 1 upon 4 pi iota and minus 3z e to the power plus 1 upon pi iota minus z square. And we have to close the bracket over here, and we compare it with the left hand side. Now on the left hand side, the constant term is c, and the constant term over here is 9 e to the power of 0. Now we know that 9 e to the power of 0 e to the power of 0 is 1, so c would be equals to 9 times 1. So we have the value of c, that is equals to 1. Sorry, 9 times 1 will be 9, so c would be equals to 9. Now, to find the value of b, we compare these two terms over here. And so we have minus 3 e to the power minus 1 upon 4 pi iota minus 3z e to the power of 1 upon 4 pi iota equals to b. And we just get rid of the z sign over here because that is, so z shouldn't be over here anymore. So this would be 3 only. and this will again we'll have 3 over here. Now, for to understand this, we have to understand identity, and I'll quickly do it over here. So let's say if I'm adding conjugates, so let's say if I have one as cos to the power theta plus iota sin theta, so this is basically the polar form, and this can be written as the power of iota theta, and e to the power minus iota theta is written as cos theta minus iota sin theta. Now, if we add these two up, so if you add these two up, we'll be adding these two terms as well. So cos and cos will add up, that will become 2 cos theta, and this will cancel out with each other. Now, in this case, to make it easier, we can take minus 3 is common over here, and let's write e to the power minus 1 upon 4 pi iota plus e to the power 1 upon 4 pi iota equals to b. Now, this term over here can be written in this form, and the theta can be replaced by 1 upon 4 pi. So we can say that e to the power iota theta plus e to the power minus iota theta is equals to 2 cos theta, and the theta over here is pi by 4. So we can write this equation as minus 3 into cos of pi by 4, 2 cos of pi by 4. So minus 3 into 2 cos of pi by 4, and that would be equals to b. Now cos pi by 4 is, so this will be minus 3 times 2 is 6, and cos pi by 4 is root 2 upon 2. So this will be root 2 upon 2. This will be cancelled. So you get minus 3 for the value of b. So b would be is equals to minus 3 root. In question number 5, the equation of a curve is xy plus y square e power minus x equals to 4. We have to show that dy dx is given like this. So in the first step, differentiate x and y, we have to apply the product. And the product rule basically is bu dash plus uv dash to find dy dx. And if we take u is equals to x, so u dash would be 1. And if we take v is equals to y, the derivative of y with respect to x is y dash. We can write dy dx as well, but this is easier to write y dash. So we'll apply the this product rule on this first term over here. So this will become bu dash, that will be y times 1 plus uv dash, that is x into y dash, plus now differentiating the second term over here. So let's take u as y squared over here. U dash will become, so we'll apply the chain rule 2y, and the derivative of y will be y dash or dy dx. Doesn't matter what we take as u and v, by the way. So v in this case would now be e to the power minus x. The derivative would be, so we multiply the derivative of the power, which will be minus 1. So this will become like this. So again applying vu dash, we'll get 2 e power minus x, uh, and then we have y and y dash plus, but this is a minus sign, so we can just write minus uv dash will become y square e to the power of minus x equals to the derivative of 4 would be 0. Now to find dy dx, we'll separate these two terms. So we'll get x y dash plus 2 e power minus x y dash is equals to, taking this on the right hand side, this will become y square plus y square e power minus x, and this will become minus y. And now taking y dash common over here, so we'll get y dash is equals to x plus 2 e power minus x y is equals to y square e power minus x minus y. Now taking this on the right hand side, we get y dash is equals to y squared e power minus x minus y divided by x plus 2 e power minus x y. Now in this question, the powers of x are positive. So let's try and make them positive. We can write in the numerator as y squared into, or y squared upon e power positive x minus y So that will be a numerator. And if you take the LCM over here, we'll get y square minus y e power x divided by e power x. And similarly, let's try and simplify the denominator. This will be x plus 2y upon e power x. Taking the LCM, we'll get, and do we have x e power x? Yes, we have x e power x. So we'll get x e power x over here plus 2y upon e power x. Now we are dividing these two terms, so the numerator divided by the denominator. First, we can write it as y square minus y e power x divided by e power x divided by this term over here. And we know that when we bring the multiplication sign, these terms will flip. So we can now write it as multiplied by e power x upon x e power x plus 2y. So this and this will cancel out. And do we have the term now? Yes. So we have the final answer. That was y squared minus y e power of x divided by x e power of x plus 2y. So that was the first part where we had to prove the dy dx. Now in part B, it says find the gradients of the tangent to the curve when x is equals to 0. So we know that dy dx represents the gradient of the tangent. So we have the expression for dy by dx already. That is as given in the first part. Now we'll put x is equals to 0 over here. Now for x equals to 0, we also need to have the value of y to find the gradients. So from the equation over here, if you put x equals to 0 over here, this will become 0 and this will become e power 0 is 1. So you'll get y squared is equals to 4. So y squared is equals to 4. So the two values of y will get will be plus minus 2. So let's first put when x is 0, the two values of y are coming as 2 and minus 2. So let's put for 0 and positive 2. So this will be 2 squared minus 2 into e power 0 divided by, so this x is 0 plus 2 times 2. So this answer would become 4 minus 2, that is 2 upon 4. So this will become 1 upon 2. So one of the gradients will be 1 upon 2. And now taking x is equals to minus 2. So minus 2 whole squared is a plus 4. And then minus 2 into e to the power of 0 is 1 upon 0 plus 2 into, so that will become 2 into minus 2. And then 4 plus 2 is 6 upon minus 4. So the other gradient would come out as minus 3 upon 2. In question number 6, we have to find the complex number z for which z plus 4 upon z plus 4 iota is real and the magnitude of z is root 10. We have to give a form in answer in the form z equals to x plus iota y where x and y are real. Now in the first step, what we can do is write it in place of z, we can write x plus iota y plus 4 divided by x plus iota y plus 4 iota. And now whenever we have a complex number of this form, we can always take the conjugate and then multiply with the numerator and the denominator. But to do that, the first thing we'll do is we'll write it like this, plus we'll take iota common in the denominator. So we'll write it as iota into y plus 4. And now we'll multiply by changing the sign. So we'll multiply by x minus iota into y plus 4 divided by x minus iota into y plus 4. Now expanding the numerator, we'll get x into x will be x squared, x into iota y will be minus xy iota, and then x into 4 iota will be minus 4x iota. Then iota y into x will become plus xy iota, then iota y into minus iota y. So iota y times y minus iota y. This is y squared. Iota is I squared and minus. Iota squared is minus, so we'll get a plus y squared over here. And then we'll multiply iota y by 4 iota. So iota y will multiply by minus 4 iota now. So this will become minus 4 iota y squared. So this will be minus 4 iota y squared. Then 4 will multiply by x, so this will become 4x. And then 4 will multiply by iota y, so 4y iota. And then 4 will multiply by 4 iota, that will become minus 16 iota. And then in the denominator, so we have multiplied the numerator. Now in the denominator, so we can take this as a and this part is b, this is a and this part is b. So we can apply a squared minus b squared. So we let it as x square minus iota into y plus 4 whole squared. Now in the question, an important part was that this, and for this it is real, it means the imaginary part is 0. So first let's write down all the iota terms. So that will become minus xy iota minus 4x iota plus xy iota minus 4 iota y squared minus 4y iota minus 16 iota. And obviously this will divide by the denominator as well. X square minus iota into y plus 4 whole squared. And this will be equals to 0. So when I cross multiply, this will be 0 anyways. Now we'll take iota common over here and we'll get minus xy minus 4x plus xy minus 4y squared minus 4y minus 16, and this will now be equals to 0. So minus x5 plus x5 cancels. And what else do we have? So we have minus 4x minus 4y square minus 4y minus 16 equals to 0. So we can now write this as minus 4x minus 4y squared minus 4y equals to 16 as well. We can divide the whole term by 4 to write it as, we can divide by minus 4 to make it easier. So x plus y squared plus y equals to 4. So that will become our first equation. And again, we'll have to check because it's lengthy. So we'll have to make sure we haven't made any uh, error with the arithmetics. So this is xy iota. We have 4 minus 4y iota squared. And we have, so let us first quickly go step by step and check if there's any mistake with the expansion. All right, so the mistake I found out was that when I multiplied these two terms over here, so this should have become a plus y squared, so that is fine. And so this y squared is fine. And then I multiply this by, so the y squared term is supposed to cancel out, and I'm just going to check it out over here. So this will be iota y into iota y, that is fine. Then iota y into iota 4. Okay, so iota y into iota 4. Okay, so we got this as 4 iota y squared. This was wrong. This is wrong because iota y into, this is 4 iota. So this is basically, this is where I made a mistake with the expansion. This should not have been 4 iota y squared. We are not getting any term as 4 iota y squared. So iota y into 4 iota. Basically, this is iota y into minus 4 iota. Iota square is minus 1. So this would have been a plus 4y only. So this was uh, plus 4y only. This should have been a plus 4y. And are we getting a term as minus 4y iota? Let us check. So yeah, this multiplies by this to get minus 4 iota, and this is fine. So we do not have this 4y squared term as this is a real term, and we are only considering the imaginary terms. So this won't be part of our terms over here. So this will cancel out. And now as this will also cancel out, so we'll get x plus y equals 2, and the signs will change as well. So this was plus 16. When we divide by minus 4, this would have become x plus y. So there's no term over here anyways. So this will also cancel out. So we have minus 4x minus 4y equals to 16, or x plus y equals to minus 4. So that's the first equation we'll get. The modulus of z is given as root 10. So the modulus of z is given by root of x squared plus y squared, and that is given as 10 over here. From the first equation over here, we can say that y would be is equals to minus 4 minus x. So we can write this as x squared plus minus 4 minus x whole squared. Taking the root on both the square on both the sides, we'll get 100 is equals to x square. And the expansion of this is the same as a square plus 2ab plus b square. So this will be 16 plus 8x plus x squared. So x squared plus x squared, that will become 2x squared plus 8x, and 16 minus 100 will become minus 84 equals to 0. Dividing the whole equation by, well, 2. So this will become 4x minus 42 equals to 0. And now, well, we have to solve it quadratically to find the value of x and y. So can we do apply middle term breaking? Let me quickly check. So 100 minus 16, this is fine. X, y would be equals to minus 4 minus x. This is fine. X square plus 4 square 16 plus this is fine. So why can't we solve this through middle term breaking? We should be able to. So this should be 7 and 6. How can we get 4? 8 4s is 32. And okay, I'll have to check this out again quickly. Okay, so again, a very basic mistake. This was a root 10 in the question. I just checked it out. This was root 10 in the question. So when I whole square this will become 10. So these are very small things that we'll have to be careful about. So this will become 2x squared plus 8x, and 16 minus 10 will be plus 6 equals to 0. We divide by 2, we get the values of x. Now we can solve it through middle term breaking. This will become x plus 3 into x plus 1. So the two values of x will be x equals to minus 3 and x equals to minus 1. Now when we take x equals to minus 3, this will be minus 4 minus minus 3. Minus 4 plus 3 is minus 1. And when we take x is equals to minus 1, we'll get minus 4 plus 1 is minus 3. So when x is minus 3, the complex number z will be minus 3 minus iota, because this is minus 1. And when x is minus 1, so we'll get minus 1 and minus 3 iota. So these will be the values for the complex number z. And apologies for the small little mistakes. Well, but they happen, and we'll have to be very careful about these in the exam. In question number 7, we have to express the function in partial fractions. So in the first step, we'll write this as a upon 3a plus 2x plus b upon 2a minus x. And this will be equals to the original fraction, and we'll just write the numerator over here, and the denominator will remain the same. Now, when we solve this, we'll first take the LCM. So a will multiply by 2a minus x, and b will multiply by 3a plus 2x. And that will be equals to 3a minus 5x. Now we will expand the left-hand side and compare it with the right-hand side. So we'll expand, this will become 2a minus ax plus 3ba plus 2bx, and this is equals to 3a minus 5x. Now we'll first compare the coefficients of x. So on the left-hand side, we have minus 5, and on the right-hand side, we have minus a and plus 2b. So this will be equals to minus a plus 2b. Now, comparing the other terms, so we have 3a remaining on the left-hand side, and this will be the constant term, and this will be equals to 2aa plus 3ba. Now, as this small a is constant, so we can just divide the whole equation by a, and we'll get 3 is equals to 2a plus 3b. So we have this was the first equation, and this will be the second equation. And now we can solve them simultaneously. So we can just simply multiply the first equation by 2 and write it as minus 10 is equals to minus 2a plus 4b. So 2a minus 2a will cancel. 3 minus 10 is minus 7 equals to 7b. B would be equals to minus 1. Once you have the value of b, we can use either of the two equations to find the value of a. So using this equation, we'll get 3 is equals to 2a plus 3 into minus 1. So this minus 3 will go on the other side, become 3 plus 3 is 6 equals to 2a. And a would be equals to 6 upon 2, and that is equals to 3. And b equals to minus 1. Now in part B, it says, hence obtain the expansion of f of x in ascending powers of x up to and including the term in x squared. So we have a as 3 and b as minus 1. We can write this as 3 upon, so the function can be written as 3 upon, so a was 3, so 3 upon 3a plus 2x, and b is minus 1, so minus 1 upon, and the denominator is 2a minus x. Now, the way to expand this is that first we'll bring this in the numerator. So let's first write it as 3a plus 2x power minus 1 minus, and this will be 2a minus x. Now, we normally what we do is we expand a term which is 1 plus b to the power of n, and the formula is 1 plus nc1, b1, and so on. So what this shows is we need a 1 over here. So if we take 3a common from over here, so we'll write it as 3a to the power of minus 1, that is taken common out. We'll get 1 plus, and this will be 2x upon 3a, and this will become our b. And similarly over here, if we take 2a, and this was power minus 1, the power of minus 1 common out, we'll get 1 minus x upon 2a to the power of minus 1. Now we'll expand each of these terms individually, and we have to expand only up till x squared. So 1 plus 2x upon 3a to the power of minus 1. The formula is 1 plus nc1. nc1 is equals to n. In this case, n is minus 1, so we'll get minus 1 into b to the power 1 plus nc2. So nc2 is given as n into n minus 1 divided by 2 factorial, or 2. So this will become nc2 will be minus 1 into minus 2, that will become plus 2 divided by 2 and multiplied by b squared. So 2x upon 3a whole squared. So we have this term as well. We can just simplify and write it as 1 minus 2x upon 3a, and then this 2 and 2 cancel, so we'll get plus 4x squared upon 9a squared. Now let's expand the second term. So that was 1 minus x upon 2a to the power of minus 1. So we know that this will be 1 plus nc1 will be minus 1. In place of b, we have minus x upon 2a plus nc2 will again be the same. So we can just simply write 2 upon 2. This will cancel out because the minus 1 into minus 2 becomes a plus 2. And this will become minus x upon 2a whole squared. Simplifying this, we'll get 1 plus x upon 2a, and this will become, so this will also be positive, so we'll get plus x squared upon 4a squared. Now we'll write the terms with the original values and then just simplify it. So this can be written as 3 upon 3a. So 3 upon 3a is multiplying by the first term, that is 1 minus 2x upon 3a plus 4x squared upon 9a squared, and over here we had 1 upon 2a. So this will be 1 upon 2a times by 1 plus x upon 2a plus x squared upon 4a squared. So the constant term will be 3 upon 3a plus 1 upon 2a. So we can just do these separately somewhere. So let's do it over here. So we have 3 upon 3a plus 1 upon 2a. The LCM of 3 and 2 is 6. So this will be 6a. This will multiply by 2. This will multiply by 3. So 3 to the 6 plus 3, 9. So this will become 3 upon 2a. So this will become 3 upon 2a. Then taking the x terms. So this will become minus 6x upon 9a squared. So we have minus 6x upon 9a squared. And the x term over here will be plus x upon 4a squared. Okay, so the LCM of 9 and 4, that is 36. This will multiply by 4. This will multiply by 9. We will get minus 24 plus 9. So minus 24 plus 9 is minus 15. So we'll get minus 15 upon 36 a squared dividing by 3. We will get 3 5s are 3 12s are. So that will be minus 5 upon 12 a squared over here and x over here. And finally, for the squared terms, well, we're running short of space. So let's quickly do it somewhere. Let's do it over here. So this will become 3 into 4, that is 12x squared upon 3 times 9 is 27 a cube. And this will be, okay, so there is no, well, we had to go. So this will be x squared, yeah. And this will be 1 upon 2a into x squared. So x squared upon 8a cube. Now, again, we'll have to take the LCM over here. So the LCM of 27 and 8, I don't know. So let's figure out what will be the LCM of 27 and 8. Uh, so that could be 8 and 27. So let's just multiply 27 times 8. 8 sevens are 56. 8 twos are 16 plus 5, 216. So that will be 216. So 27 times, I think that will be, let me just confirm it from a calculator first. So 54 plus 16. So I think that is 7. 27 times. So 20 times 7 is 140 and 7 times 49. Okay. So I'm not getting the correct answer. Okay. So that will be 8. So this will multiply by 8. So this will be 12 times 8. That will become 96x squared. And this will multiply by 20. So that will be 27. I mean, that was obvious. Why was I thinking so much? So this will be 27 as well. So 27x squared. So 90 plus 20 is 110 and 110 plus 6 plus 7, 1323 upon 216. Both of these numbers can divide by 3. This will be 41. This will be 72. So this will become plus 41 upon 72 a cube, and we'll have x squared over here, and this will be the final expansion. Again, upon checking, well, I had made a mistake. This was negative from the very beginning. So this was minus. We had to make this minus over here, and the answer will change. This will become, so this is 3 upon 3. So this will become 1 upon 2a. Similarly, over here, this will be subtracting as well. And so we'll get minus 24 minus 33 upon 36. That will become 11 upon 12. And this was, so that was a squared. And over here as well, a is in the denominator. 11 upon, and this was x. And finally, this term was also subtracting. So 96 minus 27, that would be 69 upon 216. So that will be 3 times 23 and 3 times 72. So that should be the final answer, 23 upon 72. We have a cube over here and x squared over here. I'll just confirm the answer one more time. Well, yes, the answers are correct now. And for the last part, it says state the set of values of x for which the expansion is valid. Well, for this, we'll have to remember that this term over here, which is 2x upon 3a, the modulus of this should be taken as less than 1. We'll cross multiply, so 2x is less than 3a, and then finally x, or the modulus of x, will be less than 3a upon 2. And this would be the set of values of x for which the expansion will be valid. And this is already less than 1, as this is 1 minus this value. So we'll just take this value over here and set it equals to less than 1. In question number 8a, we have to prove the identity cot square minus tan square as 4 cot 2 theta and cosec 2 theta. So in the first step, what we can do is in place of cot square, we can write, so cot is 1 upon tan, so we can write cos square upon sine square. And in place of tan square, we can write sine square upon cos square. Now taking the identity, taking the LCM over here, so we'll get cos power 4 minus sine power 4 divided by sine square cos square. Now we'll try and apply some identities over here. For cos power 4 minus sine power 4, we can write it as cos square minus sine square into cos square plus sine square divided by sine square cos square. Now what we know is that sine square plus cos squared is 1, so that's fine. And we know the identity that cos 2 theta is the same as cos squared theta minus sine squared theta. So in place of cos square minus sine square, we can write cos 2 theta. So let's write cos 2 theta over here. And in the denominator, we have sine square cos square. Now, as for sine square cos square, we also know that sine of 2 theta is the same as writing 2 sine theta cos theta. And let's say if we whole square both the sides, we can write it as sine square of 2 theta is equals to 4 sine square cos square. So sine square cos square can be written as sine square 2 theta upon 4. So in place of sine square cos square, we can write, so let's write this as cos 2 theta upon sine square 2 theta. So in place of sine square 2 theta, let's write it as sine 2 theta into sine 2 theta. And you'll just get why this is important to write it like this. And this is divided by 4. So the 4 comes up in the numerator. And cos 2 theta upon sine 2 theta, well, that is cot 2 theta. And 1 upon sine 2 theta is cosec 2 theta. So we'll get cosec 2 theta as well. And this 4 comes up in the numerator. So that will become 4 cot 2 theta cosec 2 theta. Now in part B, it says, hence solve the equation cot square minus tan square equals to 5 sec 2x. So what we can do is we already have proven this identity for cot square minus tan square. So let's write 4 cot 2 theta cosec 2 theta over here. So in place of this, we'll write it as 4 cot 2 theta cosec 2 theta or 2x is equals to 5 sec of 2 theta. We'll just write in x in the next step. Now, as you have to solve it, so you have to bring it in the form of either sine or cos. So cot can be written as cos 2 theta upon sine 2 theta. Cosec can be written as 1 upon sine 2 theta. And sec can be written as 5 upon cos 2 theta. Cross multiplying both the sides, so that will become 4 cos square 2 theta equals to 5 sine square of 2 theta. Now sine square upon cos square, that will become tan square. So you can write it as 4 upon 5 is equals to tan square of 2 theta. Taking the square root, we'll get tan 2 theta is equals to square root of 4 upon 5. And now we'll take the inverse of this. So, or now we can write just x over here. So 2x would be tan inverse of square root of 4 upon 5. So taking shift tan inverse of root, and we have to make sure it is in degrees. Okay, so we'll keep our calculator in degree, and this will be 4 upon 5. So what we are getting is 2x is equals to 41.8103. And we'll make the quadrants over here. Now, as we have a square root, so we can take it in the positive and the negative quadrants of tan. So this is the positive quadrant, this is the negative quadrant. One of the angles is 41.81. We'll get the other angle, we'll make this 41.81 over here as well. So in the first step, what we can do is we can write this as 2x will be equals to 41.81, and this will be 180 minus 41.81. And now 2x would be is equals to, so 180 minus 41.81, that's equals to 138.19. And now we'll divide both the answers by 2. So dividing this by 2, we'll get 69.09. This is 69.095, and this will become 20.905. And we have to give our answer for degrees. We always give it to one decimal place. So the values of x will be 20.9, and the other answer will become 69.1 degrees. And as we just have to give our answer between 0 to 90, so even if we had taken this value over here, so this would have become 180 plus 41.81. And even if we had divided this by 2, this would have still come out as greater than 90. So the only two possible answers would be 20.9 and 69.1. Okay. In question number 9, in part A, we have to find a vector equation for line L and it passes through B and C. So to find a vector equation for any line, we need a point on the line and the direction represented by B. So as it passes through B and C, the direction B, C would be C minus B. So C minus B would be 2, minus 1, 3, minus 1, 2, and 0. So 1, minus 3, and 3, B, not A. So B point is 1, 3, and minus 2. 1, 3, minus 2. So we'll get 1, minus 4, and 5. So in vector form, you will write your equation as R is equals to, let's take the point B, I plus 3j minus 2k plus lambda into iota minus 4j plus 5k. This would be the vector form. Now in part B, it says the point P is the foot of the perpendicular from A to L. So this is the point A. This is the line L over here. And point P is the foot of this perpendicular. So we have to find this point P. Now to find this point P, what we have to first understand is that P lies on the line L. We have the equation of line L. Let's write it in parametric form. That will be 1, 3, minus 2 plus lambda 1, minus 4, and 5. Now to find the coordinates of P, we need to have the value of lambda for this particular point. When we plug in the value of lambda, we'll get the coordinates for P. Now to find the value for lambda, what we can do is, we know that AP is perpendicular to the line L. So when we apply this formula to, okay, so this is the formula, A dot B is equals to AB cos of theta. We know cos theta is 90 because it's perpendicular. Cos 90 is 0, so this will be equals to 0. So first we need AP. We already have the direction of line L. How will we find AP? AP would be P minus A. Now as P lies on this line L, we can write its coordinates in the form 1 plus lambda, 3 minus 4 lambda, and minus 2 plus 5 lambda. So this will become 1 plus lambda, 3 minus 4 lambda, and minus 2 plus 5 lambda. Minus A, the coordinates of A are given as 1, 2, 0. So 1, 2, 0. Simplifying this, we'll get 1 minus 1, 0, 3 minus 2, 1, and minus 2 plus 5 lambda. So we have the direction for AP as well. Let's write it over here. Lambda, 1 minus 4 lambda, minus 2 plus 5 lambda, times by the direction of line L, which is 1, minus 4, and 5, as we found in the last part, equals to 0. Lambda into 1 is lambda, minus 4 plus 16 lambda, minus 10 plus 25 lambda. So minus 4 minus 10 is minus 14. Lambda plus 16, 17. 17 plus 25 is 42. So lambda is equals to 1 upon 3. Now, once you have the value of lambda, you plug it back into the equation of line L and you will get your coordinates for point P. So
This was basically the equation for line L over here. We'll substitute 1 plus 1 upon 3. So P would be 1 plus 1 upon 3, 3 minus 4 into 1 upon 3, and finally minus 2 plus 5 into 1 upon 3. So 1 plus 1 upon 3, that's 4 upon 3. 3 minus 4 upon 3, 9 minus 4 is 5, so 5 upon 3. And minus 6 plus 5 is minus 1 upon 3. And these will be the coordinates of P. You can write OP as a 4 upon 3 iota plus 5 upon 3j minus 1 upon 3k. Okay. देखो, in part C, it says the point D, the reflection of A. So this was point A. When we talk about reflection, what do we mean? It is always perpendicular, right? So do we already have the midpoint, which is P? Do we have it? So can I say point D will be over here and the midpoint of A and D will be P? Okay, lovely. So do you know the midpoint formula? That is x1 plus x2 upon 2, comma y1 plus y2 upon 2, comma z1 plus z2 upon 2. Now we have the midpoints in the form of P. They are 4 upon 3. So this x value is equals to 4 upon 3, right? So you will write 4 upon 3 is equals to, what are the coordinates of A? 1, 2, 0. 1, 2, 0. And this point, I don't know, x1, y1, z1. So 1 plus x1 upon 2. Cross multiply 8 is equals to 3 plus 3x. 8 minus 3 is 5. So x would be equals to 5 by 3. Then this will be equals to the y coordinate of P, because P is the midpoint. That is 5 upon 3. So 5 upon 3 will be is equals to 2 plus y upon 2. 10 is equals to 6 plus 3y. 4 is equals to 3y. Y equals to 3 upon 4. And finally, this is equals to the z coordinate, that was minus 1 upon 3. Which part? This, isn't it minus 1 upon 3? And for z, that is minus 1 upon 3 is equals to 0 plus z upon 2. Cross multiply minus 2 is equals to 0 plus 3z. Z would be equals to minus 2 upon 3. And that will be the coordinates of point D. In question number 10, it says that the variables x and y satisfy the differential equation. It has given that y is 1 upon 12y when x is equals to 1 upon 2 pi. Solve the differential equation. Now, to solve the differential equation, the first thing we have learned is we'll bring the y terms together. So this is sine of 4y divided by sine of 2y dy is equals to x sine of 3x dx. So the first step we always do in differential equations is we separate the y terms with dy, the x terms with dx. That's the first step. The next step is we integrate. Now we integrate both the sides. I'll put up the integration sign on both the sides. Now to integrate sine of 4y upon sine of 2y, I will have to use an identity over here. So for sine of 4y, I can use an identity. I know that sine of 2a is equals to 2 sine a cos a. Similarly, this can be used in the sense sine of 4a is equals to 2 sine of 2a cos of 2a. So I can, in place of sine of 4y, I can write 2 sine of 2y cos of 2y divided by sine of 2y. Sine of 2y and sine of 2y cancels. Now I'm left with a very simple term. Now I'm left with a very simple term, which is 2 cos of 2y that I have to integrate on the left hand side. On the right hand side, I have x sine of 3x. As two different terms are multiplying, I will apply integration by parts. So for integration by parts, we know that u dv, when we integrate this is given as uv minus v du. And we apply the late rule over here where we take the algebraic term as u. Okay. So LATE, algebraic term will be taken as u. So u will be equals to x and du will be 1. V will be given as sine of 3x and dv, sorry. And v will be is equals to the integral of sine is minus cos. So minus cos 3x upon 3. And we'll apply this in the formula. So uv will become minus x cos of 3x upon 3 minus v du. So v du will become, so this is already a minus over here. I will just still apply it over here. So this is cos of 3x upon 3, and this minus I will bring it outside and make this sign a positive. Integrating cos of 2y, integral of cos is sine. So sine of 2y upon 2, and this 2 remains over here, is equals to minus x cos of 3x upon 3. Integral of cos 3x will be sine 3x upon 3. So this will become upon 3 times c, this will become 9 plus c. Now to find the value of c, we have been given the initial conditions where y is 1 upon 12 pi and x is equals to 1 upon 2 pi. Cancel this over here. Sine of 2 times 1 upon 12 pi is equals to minus x is 1 upon 2 pi. And this minus is already over here, so be very careful. X is minus 1 upon 2 pi. No, plus 1 upon 2 pi, my bad. So x is positive 1 upon 2 pi into cos of 3 into 1 upon 2 pi divided by 3 plus sine of 3 into 1 upon 2 pi divided by 9 equals to c. Sorry, plus c. So this will become sine of 1 upon pi upon 6, which is half if you put it in the calculator. So sine of pi upon 6 will become half is equals to minus 1 upon 2 pi is in the numerator. Cos of 3 upon 2 pi. 3 upon 2 basically means 270, which is equals to 0. If you put this in your calculator, cos of 270 is 0, or if you put cos of 3 upon 2 pi in the calculator, that will come out as 0. Sine of 3 upon 2 pi, when I put it in the calculator, that comes out as minus 1. So this will become minus 1 upon 9 plus c. So this will be 0. C will be 1 upon 2 plus 1 upon 9 is equals to c. 9 and 2 LCM is 18. So this will be 2 times 9, 9 times 2. So I hope this maths everyone knows. Yeah. So C is equals to 11 upon 18. And finally, my answer, because I have found the value of C as well, I can now write it as sine of 2y is equals to minus x cos of 3x upon 3 plus sine of 3x upon 9 plus 11 by 18. And that's it. So that's your first part done. And do we have to make y the subject? No, we don't have to. Unless it says giving y in terms of x, you will leave your answer as is. Okay? Now the next part. Given that y is between half pi and 0, find the values of y when x equals to 0. Now in the same expression, I will write x equals to 0. So I will get sine of 2y equals to minus x is 0, right? So if x is 0, so 0 into cos of 0 upon 3 plus 1 upon 9 sine of 0 plus 11 by 18. Okay, so this is 0, this is also 0. I will get sine of 2y equals to 11 upon 18. And we have to make sure our calculators are in radian mode. And y will remain between these two values. So 2y would be equals to sine inverse of 11 upon 18. And This is where your calculator comes in handy. One of the values would be the what's the basic angle? Sine inverse of 11 upon 18? 0.657. So you never forget your basics. You will make your basic angle over here and over here. And now when I find the value of y, so one of the answers will be 2y is equals to 0.657. And the other value would be pi minus 0.657. 2.484. And then finally you divide both of these answers by 2. So this answer will become 0.32, 0.3285. So 0.329, and this will become 1.242 or 1.24 to three significant figures. And that's it. In question number 11, the diagram shows the curve y is equals to root x sine 2x for x greater than 0 and less than half pi. The curve has a maximum point at m where x is equals to a. Show that tan 2a is equals to minus 4a. Now, as it has a maximum point at m, what we can do in this question is we'll first find the dy by dx and put it equals to 0. So we'll take this as u and this as v. So as u is root x or x power half, so u dash would be half x to the power of minus half, and v is sine of 2x. So v dash would be, so derivative of sine is cos 2x and the derivative of 2x is 2. Now substituting this in the formula vu dash, so that will become half x power minus half into sine 2x plus v uv dash. So this will be x power half into 2 cos of 2x, and now we can put it equals to 0. Now we'll to solve this, we'll bring it on the left hand side, any of these terms. So let's bring half x over here. So this will be half, and let's bring the x in the denominator as well. So half root x sine 2x is equals to 2x power half cos of 2x. Now this is root x and this is root x. When it multiplies, that will become x. 2 and 2 will multiply to become 4. We'll get sine 2x is equals to 4x cos of 2x. Sin 2x upon cos of 2x will become tan of 2x is equals to 4x. Now the maximum point is at x is equals to a, so we can just simply write it as tan of 2a is equals to 4a. Now it says in part B that show by calculation that a is between 0.9 and 0.95. So in the first step, we will make sure that we write it as tan of 2a minus 4a is equals to 0. Now, this is a very common mistake students make. They forget to bring the a, this term on the left hand side and make it equals to 0, and then try plugging in the values, and they do not get a change of sign. So this is the first step you will have to do. Now you'll plug in the value 0.9. So when I do tan 2 into 0.9 minus 4 into 0.9, what we'll get is, so tan into 2 into 0.9, and we have to make sure the calculator should be in radian mode. So converting the calculator first to radian mode, we'll write it as tan of 2 into 0.9 minus 4 into 0.9, and we are getting minus 7.88. And now taking 0.95 as our value. So when we substitute 0.95, we'll get tan of 2 into 0.95 minus 4 into 0.95, and that becomes, okay, so why am I getting negative in both the cases? Wait. Okay, so that was minus 4a. So just have to make a correction. We should have had a negative sign over here, which would have made this as negative 4a. So this would have become a plus 4a over here. And then let's try and do it again. So now substituting the values again, but with a positive sign. So this is giving positive 0.87, as this is a plus over here. And then when we do tan into 2 into 0.9 plus 4 into 0.9.
we are getting minus 0.686. So this change of sign basically represents that 0.686, that the root lies or the value of a lies between 0.9 and 0.95. It says that show that if a sequence of values given by the iterative formula is given like this, converges, then it converges to A. So what we'll have to do is that the given equation that we had over here, okay, where was it? Yeah, tan 2A is equals to 4A. So we had tan 2A is equals to 4A, and we have to show that it converges to A. So we'll try and rearrange our equation in this form. Now, what we can do is, and let's not get confused with this term over here, because, well, we can just simply write it as 2A is equals to tan inverse of 4A or 4x. Now, this thing over here, we'll try and use an identity over here. So an identity that we can use for tan is, okay, so one of the identities is tan of x is equals to 1 upon pi minus 90 minus tan of x. So that is 90 minus tan of x. Now, once we use this identity over here, or instead it is pi minus tan of x. And we can confirm this identity as well. So let's say if we take a value of tan as any value we can take over here, let's take tan 30 over here. Let's do it in terms of degrees first. So to confirm this identity, what we'll do is we'll write tan of 30. So that is root 3 upon 3. And then we'll check if it is the same as 1 upon 180 minus tan of 30. So 180, okay, so that would be pi. So pi minus, so where's pi? Pi minus tan of, but we're doing it in degrees now. So I think let me just confirm the identity over here, because we'll have to use an identity over here. We already have 2A is equals to tan inverse of 4A. So A would be is equals to tan inverse of 4A, and this will basically be dividing by 2 over here. And now what the only thing is, okay, so again, I missed out on the negative sign over here. So this was a minus 4A over here. Now it becomes clear. So if we have tan inverse of minus x over here, this is the same as writing pi minus tan of x. So this is the same thing as pi minus tan of x. So in place of, once we get tan inverse of minus 4a, we can write it as pi minus tan inverse of 4a, or x basically is the same thing. And then this 2 divides over here, so we can write 2 over here, and we'll get the expression over here like this. And in part D, it says use the iterative formula to calculate a correct to 4 decimal place. Now, this thing is the this part is the most simplest one. We start off with the initial value, and we can take the initial values between 0.9 and 0.95. So let's take the initial value of a as 0.925. So we'll get 1 upon 2 into pi minus tan inverse of 4 into 0.925, and then we'll keep on substituting until we get a constant answer. So we'll get 1 upon 2 bracket pi bracket. Okay, so we get pi my 1 upon 2 bracket pi minus shift tan inverse of 4 into 0.925. So we are getting, okay, and again, I forgot to do one very important thing, that was to make sure the calculator is in radian mode. So we'll write it again, 1 upon 2 bracket pi minus tan inverse of 4 into 0.925, and we are getting 0.9173, and we have to write all of these to 6 decimal place. So 91738, and then substitute it back over here, and we are getting the second answer is 0.918425, and then we get 918281, and then we are getting 918301, and then we are getting 0.918298, and then we are again getting 0.918298. So we are getting the same answer again, and as we have to give our answer final to calculate a correct to 4 decimal places. So to 4 decimal places, we are getting 0.91829 consistently now. Even if I keep on substituting this, we are still getting the same answer. So the final value for A would be 0. So for 4 decimal place, this will become a 3. So 9183 would be the final value for A.